In the last lecture of a C programming, we have discussed what are constants, then various data types in a C, and then expressions. Now the next article which we are going to discuss is statements in a C. In the expressions, we have seen that expression is a part of statement. Statement causes computer to carry out some action. Statement causes computer to carry out some action. And statement is identified from semicolon. Semicolon is a statement delimiter. So whenever semicolon will be there, you will identify that the whatever is written is a statement. So statement is identified from semicolon. There are various types of statements. The first type of statement is null statement. Null statement. As its name indicates, null, nothing is there except single character semicolon. Single character semicolon is called as null statement. So nothing will be there. This is a null statement, where I have already told that the semicolon is a statement delimiter, means statement terminator. Just like in English, full stop is a statement delimiter or a statement terminator. Semicolon is a statement delimiter or statement terminator in a C programming. Then next type of statement is expression statement. Expression statement. Expression statement. Expression followed by semicolon is called as expression statement. Expression followed by semicolon is called as expression statement. Many C statements are expression statements, such as assignment statements like x1 equal to minus b plus d divided by a star b. This assignment statement, this is expression followed by semicolon is an expression statement. Okay, this assignment statement precisely. Then in the expression statement, we have expression followed by semicolon. Then we'll go to another example of expression statement is this function call big A, B, C. This is what is called as a function call. We shall see what are function calls as we will go ahead. Then third type of statement which we have are compound or block of statement. Third, compound statement or block of statements. Block of statements. Compound statement consists of one or more statements enclosed in pair of braces. Compound statement or block of statement consists of one or more statements enclosed in pair of braces, and such a blocking is made for specific purposes such as execution repetition of group of statements. Such as execution repetition of group of statements. Here I am writing a compound statement which will be written within pair of braces. Here I am writing pi equal to 3.14, 15, 93, semicolon. So this is expression statement, precisely assignment statement. Then from, if I know radius, then I can calculate circumference is given by 2 pi r, 2 times pi times radius, 2 pi r. For multiplication, the star or asterisk symbol must be explicitly written. Now again, knowing radius, you can calculate area of a circle. Area equal to pi r square. So pi r square means radius multiplied by radius, star radius. So all these are statements because each one is delimited by semicolon, and we have group of these 3 statements, and we have made this particular block in order to have repeated execution of this particular block. So given a radius, whenever you want to calculate circumference and area of a circle, you will go to this particular block and will get this particular block executed. Then fourth type of statement which we have are labeled statements. Labeled statements. Fourth type of statement which we have are labeled statement. Any statement may be preceded by a prefix that declares an identifier as a label name. Labels in themselves do not alter the flow of control, but gives provision so that through other statement, transfer of control to the labeled statement is possible. So you can label any statement. For example, you have this particular statement, you can label it as a case 10 and then colon. So this prefix is an identifier and is a label name. Label in this particular statement will not alter the flow of control, but through other statement, suppose few statements are there, and then if I am writing here go to case 10, then control will jump back to this particular labeled statement. So through other statement such as go to case 10, you can transfer the control back to this particular labeled statement. Then after labeled statement, we will go to fifth type of statements, which are conditional control statements. Conditional control statements. Conditional control statements. As its name indicates, condition will decide the flow of control. Condition will decide the flow of control. In this case, you have if statement, if else statements and so on. If else. These are examples of conditional control statement. Depending upon the condition, whether it is true or false, or depending upon the outcome of the condition, you can decide whether statement is to be executed or skipped. Okay. Then last type of statements, which are loop control statements. Loop control statements. Loop means repeated execution of the same block of statement. Loop means repeated execution of same block of statements, and such a looping structure which are there in a C. There are 3 very commonly used loops in a C. Those are while loop, then second one is do while loop, and third one is for loop. These are 3 commonly used loops in a C where repeated execution of same block of statement is there, depending upon, of course, the condition, whether condition is true or false. So after these 6 types of statements, We will go to the next article, namely symbolic constants. Symbolic constant, article H, symbolic constants. Symbolic constant is a name that substitutes for a sequence of characters. Sequence of characters may be numeric constant, single character constant, or string constant. These symbolic constants are usually written at the beginning of the program, and the general form of the way this symbolic constant is defined is hash. There is no space in between, hash defined, space is not there, and then name and text. This is general form of how symbolic constant is defined. Name is a symbolic name usually written in uppercase letter, and text is a sequence of characters that substitute for this symbolic name. Remember, this text does not end with semicolon, since symbolic constant definition is not a true C statement. The examples are hash define pi. Pi is a symbolic name written in an uppercase letter, and sequence of characters that substitute this name is 3.141593. Similarly, hash define true, written in uppercase letter, so true is a symbolic name, and sequence of characters that get substituted for this is 1. 1 is a numeric constant. This is also a numeric constant. Hash define false. False is a symbolic name written in uppercase letter. 0 is substituted for false. Then hash define, here I am writing friend, is a symbolic name, and a sequence of characters that substitutes for this name is Sushan. Remember, this is variable, this is also variable. So what I am assigning to this symbolic name is variable, which is not true. So therefore, I must make this particular variable as a string constant. Now this constant can be assigned to friend. So these are examples of symbolic constants. Then after symbolic constant, we will go to the next article, namely operators. Operators in C. Operator is a symbol that tells computer to carry out some arithmetic or logical manipulation, and the data items on which operator act are called operands. If an operator needs 2 data items for its operation, then that operator is called as a binary operator. Similarly, unary operator needs for a single operator for its operation, and ternary needs 3 operands for its operation. Okay. Binary needs 2 operands, unary needs 1 operand, and ternary needs 3 operands for its operation. So let us see arithmetic operators first. Arithmetic operators. Arithmetic operators are either binary or unary. Binary because they need 2 operands for their action, for their operation. So binary operators. First one is binary operators. Binary operators. There are 5 binary arithmetic operators in C. So let us see their symbols and their purpose. So here we have operators, and here the purpose of those operators. Plus, the purpose is addition. Then minus, purpose is subtraction. All these are binary operators. Then star or asterisk for multiplication. Then forward slash for integer division. Integer division. Then percent for remainder after integer division. For remainder after integer division. After integer division. Let me explain these two operators. 5 divided by 2, the answer is 2, and it is not 2.5. Is not 2.5 because this is integer division. 5% 2, remainder after integer division is 1. Remainder after integer division is 1. So these are binary operators which we have. This percent or remainder after integer division is also called as modulo division or modular division, and the operator has a modulus operator. Then in arithmetic operators, we will go to next type of operators in arithmetic. The second category of arithmetic operators is unary operators. Unary operators. Second, unary operators. Okay. These are the operators which need only one operand for their action, which need only one operand for their operation. In C, there are these 4 unary operators: unary plus, unary minus, increment, which is plus plus, and decrement, minus minus. These are 4 unary operators in a C. Remember, this unary minus is distinctly different from subtraction operator. Subtraction operator needs 2 operands for its operation, while the effect of application of unary minus to an operand results in negated value of operand. Any negative number is unary minus operator followed by a positive numeric constant. That is what the meaning of unary minus is. And unary plus operator such as minus k is a negative number, which is unary minus followed by positive numeric constant. On the other hand, unary plus means such as plus k, which is value of that operand, which is value of the operand. Then increment, plus plus, and decrement operators, they are very commonly used in C programming, plus plus and minus minus. And what this increment operator does, it increases value of an operand with unity, and decrement operator reduces or decreases the value of an operand by unity. And there are 2 ways by which this increment and decrement operators are used. For example, plus plus x, this is one way of using increment operator, or x plus plus. Plus plus x means first value of x is incremented by unity and then value of x is used in the program. X plus plus means value of x is used first and then incremented. Increment first and then use and then increment. Similarly, decrement operator, minus minus x and x minus minus. These are 2 ways of using decrement operator. Value of x is decremented first and then it is used. Value of x is used first and then decremented. Then one more unary operator is there, which is called as the size of operator, size of, which will return the size of an operand in bytes. The way it is used is size of, say, operand is integer value 2. The result is, since it returns value of an operand in bytes, 2 being integer, to store integer we need 2 bytes, therefore 2 will be the answer. Even if it is 3, 4, 5, 7, the answer would be 2 bytes, because size of integer 7 is 2 bytes. Similarly, size of 4.7 or 8.7 being a float, to store a float we require 4 bytes, so it will return the size of this floating point number in bytes, and the answer will be 4 bytes. So this is size of operator. So these are all unary operators: unary plus, unary minus, increment, decrement, and size of operator. After these unary operators, we will go to next type of operators, namely relational operators. After arithmetic operators, we have relational operators. We have relational operators. Relational operators are used to test the value of the value of the expression, There are 4 very commonly used relational operators in C: less than or equal to, greater than or equal to, So this is used to test the value between 2 operands or 2 data items, and the result of all these relational operations or relational expressions would be either true or false, 1 or 0, or yes or no. Then closely associated with these 4 relational operators, we have 2 equality operators, namely equal to or not equal to. Example of equal to: x equal to y. The meaning is, whether value of x is same as value of y, the answer would be either yes or no, or true or false. Similarly, if x is not equal to y, then answer would be 1 or true. If x is not equal to y, then its answer would be 1. Next time we will discuss assignment operators and conditional operators and casting. So let us stop here.